Hey everyone, have you ever wondered why your perfume seems to disappear into thin air, or how a pot of water starts bubbling and steaming when you heat it? Well, it's all because of something called vapor pressure. Don't worry, by the end of this video, you will totally get it, even if chemistry feels confusing right now. So let's start with this. You imagine that you and your friends are all sitting really close to each other, chilling and chatting. You're happy to stay close because everything feels cool and comfortable. This is kind of like the molecules in a liquid. They stay together, hanging out because of intermolecular forces, which are like invisible bonds, holding them together. But what happens when things heat up? As you add heat, things get hot. You and your friend starts to feel a little bit warm and even warmer and even uncomfortable. So even though you like each other, you start moving away. So let's see the particles here. It's like you are inside the beaker. You are sitting with your friends. But then when you heat things, that's what exactly happens in a liquid. When the molecules get enough energy from heat, they start moving apart. This process is called vaporization. So the molecules start to move from the liquid into the gaseous phase and start to move up into the vapor. It's when the liquid turns into a gas like water turning into steam. Now, before that liquid turns into a gas, something really interesting happens, and that's what vapor pressure is. But what it is, let's go back to you and your friends. As you move apart, some of you start leaving the room, but you are still connected in a way. That's like molecules in liquid. Some of them get enough energy to escape into the air above the liquid, forming vapor. If you are in a closed space like a bottle or flask, this vapor starts bumping into the walls of the container. When the vapor particles bump into the walls of the container, this creates pressure. We call this the vapor pressure. So, how does this relate to the temperature? Well, it's easy. The hotter it gets, the more energy the molecules will have. The more energy, the more of them escape into the vapor, and the higher the vapor pressure gets. It's like your friends saying, phew, it's getting hot in here, and more of them leaving the room. The more people leave, the more crowded it gets outside here, and the more pressure you will be having in the vapor pressure up here above the liquid. But what happens if you turn the temperature down? If you turn the temperature down, the some of the vapor starts changing and condensing back into the liquid. So the particles are here, which in the vapor starts to decrease. Imagine the room cooling off, your friends feel more comfortable, so they come back inside and sit together again in the liquid. That's what happens with vapor pressure. When the temperature drops, the fewer molecules escape into the vapor and the vapor pressure goes down. Now, there is something super cool that happens at this point. If the rate of the molecules escaping the liquid and entering back into the vapor equals the rate of the vapor molecules condensing back into the liquid, we reach what's called dynamic equilibrium. It's like half of your friends are going outside and the other half are coming back inside. Perfect balance. When this happens, the vapor pressure stays constant. And here is something neat. Every liquid has its own unique vapor pressure. Why? Because the intermolecular forces holding the molecules together are different for every liquid. Water has strong forces to its vapor pressure is lower, but something like alcohol, it has weaker vapor pressure. So, it has a weaker forces, so it has vapor pressure which is high. Let's wrap it up. Vapor pressure is all about how fast molecules can escape from a liquid into the vapor phase.